Welcome back. In this section, we're going to look at Venn diagrams, which is a sort of visual display that can be used if we wanted to visualize sets within a universe. So when we're talking about a Venn diagram, we're going to be talking about a diagram that looks sort of like what we have below. There'll be a rectangle, and the rectangle that will represent the universe. And inside the universe, we'll have one or two or maybe three sets, and each one of those sets will be represented by circles. So I've got a universe here with two sets, A and B, and I've drawn the A and the B as possibly overlapping because unless I know otherwise, unless I know that the sets are disjoint, then I'll draw them as possibly overlapping. And if we're thinking about this Venn diagram, that really takes our universe and it splits it into four sorts of areas. We'll talk more about this in future sections, but there would be the part where the A and the B overlap, what A and B both have in common. There would be the part where we're just inside of A, we're not inside of B. There would be a part where we're inside of B and not inside of A. And then, of course, there'd be the part where we're not inside of anybody, where, of course, we're always inside the universe, but maybe we're not inside of A and we're also not inside of B. So some of the things we're going to want to do would be if I had some sort of an expression like A union B, where would that be shaded on my Venn diagram? Or the reverse, if I have a shaded in Venn diagram, what are the sets that it's referring to? All right, let's start with an example. And we're going to start with two sets at first and then work our way up to three sets. So I've got seven different sets, seven different Venn diagrams rather, and I'd like to figure out who is the shaded set for each of them. Just one thing as an aside here, sometimes the answer will be very simple and sometimes the answer will be fairly involved. Even though there's an A and a B in my Venn diagram, that doesn't necessarily mean that my answer will always involve an A and also a B in some way. Maybe my answer might just involve the A or just the B. So just keep that in mind. I'm looking at the first Venn diagram, and if you said who has been shaded in the first Venn diagram, I've shaded the entire circle for A. So I'm indicating that what's been shaded is set A. So there we go. I'll just say that's what's been shaded. Similarly, for the second one, I've shaded the entire circle for B. So if I were to describe who's been shaded, I would say you've shaded set B. For the next one, what's been shaded, this is the overlap. This is where A and B overlap with each other. So I've shaded all the things that are inside of A and also inside of B. I've shaded A intersect B. And for the next ones, I'm looking at this one. I have three regions shaded. I have only A, only B. I have A and B together. If you're thinking about what this means, you've shaded in anything that's inside of A or inside of B or that's inside of both of them. What I've shaded here is A union B. Okay. Now, there might be more than one way for us to come up with a way to describe something, but I'm always going to try to keep it as easy as possible. So if I'm looking at this next example, the thing that I'm noticing is that this Venn diagram is actually the opposite of our very first Venn diagram. Notice that in our very first Venn diagram, we shaded in only the things that were inside of A, and in our Venn diagram that we're working on now, I've shaded in the opposite. In other words, I've shaded in everybody who is outside of A. So I could refer to that as A complement. All right. Sometimes, though, it's not going to be as simple as just saying just A, just B, or an A complement. Something like this example where it's not just B, because if it was all of B, we would need to have the middle part shaded as well. And it's certainly not A complement, because if it was A complement, we would have to have the outside shaded as well. So how would I describe what I've got here? Well, the good news is I can describe any individual region by saying which circles am I inside of and which ones am I not inside of. So if you were describing the current shaded region, I would say, well, that current shaded region is inside of B, and at the same time, remember, and is an intersection. So when I say and at the same time, we're talking about an intersection. So we are inside of B, and at the same time, we are not inside of A. So in other words, we are inside of B, and we are inside of A complement. So that's how I could describe this one little region. And in fact, any one of these four regions in my Venn diagram, I can describe it as being either in or outside of A, and at the same time, either in or outside of B. So for this shaded region, you are inside of B, but you are not inside of A. So you're inside of B, and you're inside of A complement. So you could do that actually with this last one if you wanted to. You could say for this last one, the shaded region, where are you? Well, I'm not inside of A, so I'm in A complement. And at the same time, I'm not inside of B, so I'm inside of B complement. So that's one answer that you could give. The other answer that you might feel like giving for this one is, if you notice again the relationship between the first Venn diagram in this row and the last one, these are opposites. The first Venn diagram, we shaded in everybody who is inside of A or B or both of them, and in our last example, we've done the opposite. So in other words, our last example is the opposite of A union B. In other words, it's A union B complement. So this is a good thing for us to notice, that there's going to be often more than one way for us to describe a Venn diagram. So that last example, both would be correct. A complement intersect B complement, that is where you are. A union B complement, that's also where you are. All right, let's do another example. And this time we're going to go and do the reverse, which is we got an expression, but we'd like to go and shade things in our Venn diagram. So I'm going to need to do the same breaking things down into steps that I did before when I was listing elements. So for something like A union B complement, I'd first need to know where A union B is. And then once I've done that, I can figure out where A union B complement is. So let's start shading. A union B, that would be anybody who's inside of A or inside of B or inside of both of them. So there we go. I've shaded all the things that are inside of A union B. And so A union B complement, you'd be shading in everything else. And the everything else here, that would be the outside of our two circles. There we go. We've shaded in A union B complement. I'm going to do the same sort of thinking for the next one. So if I've got an A complement intersected with B complement, I'm going to need to do really three things. I'll need to know where is A complement. Then I'll need to know where is B complement. And then once I've done that, I'll ask myself, what do they have in common? Where does A complement overlap with B complement? So I'll start with A complement. That's everybody outside of A. So that would be this stuff that's only inside of B. It would also be all of this stuff that's on the outside of A and also on the outside of B. All of those areas there that I'm shading, those two regions, those are the things that are outside of A. And then for B complement, all the things that are outside of B, I'm going to do same sort of an idea, shading all the things that are outside of B. And there's two regions being shaded there, the part that's outside of both sets and the part that's only inside of A. Okay, so I've shaded in A complement, I've shaded in B complement, and now for the intersection, I'm going to ask myself, what do they both have in common? Because remember, for an intersection, you're asking who was shaded for both. Where do they overlap? And for the two diagrams, the area that was shaded in both of them was the outside. So A complement intersect B complement is just the exterior. Fun thing for us to notice, and this is sort of similar to the last question where I pointed out that sometimes a set could be described two different ways. Here we might notice that my Venn diagram that I ended up with for A union B complement is the same Venn diagram as the one that I ended up with for A complement intersect B complement. If we notice that these two are the same, then we can conclude that A union B complement is the same thing as A complement intersected with B complement. And that's because they have exactly the same Venn diagram. And if you have the same Venn diagram, you are the same thing. So for this question, for A and B, we've investigated and found out what happens to A union B complement and A complement intersect B complement. It turns out they're the same. Okay, let's do the next, same sort of an idea, and this time we can be a little bit speedier because we know a little bit better what we're doing. A intersect B complement, I'll first find A intersect B, and then I will do the opposite. So A intersect B, that's where do the two things overlap? And it's just in that little slice there. So A intersect B complement, who didn't I shade? Well, that would be all the stuff that's on the very outside, as well as the stuff that's just inside of A, as well as the stuff that's just inside of B. So everybody except for the very middle. And next one, A complement union B complement. So again, I'm going to shade in A complement, shade in B complement, and then I'll ask myself, what is the union for the two sets? A complement, we know where that is. That's everybody that's outside of A. That's all of that exterior together with the only inside of B part. For B complement, it's everybody outside of B. So that's, again, the exterior as well as the only A by itself part. So that's everybody who's outside of B. And then for a union, remember a union is anything that was shaded in one diagram or shaded in the other or shaded in both. The only B part was shaded in one of the diagrams, so it will need to be shaded. The only A part was shaded in one of the diagrams, so it'll need to be shaded. The exterior was shaded for both, so it will need to be shaded. The only thing that we won't be shading in will be the very middle, and that's because the very middle wasn't shaded in for anybody. So we've shaded in the very outside, only A, only B. And again, we might notice, again, these last Venn diagrams are identical, so we could again come up with another little conclusion that A intersect B complement is equal to A complement union B complement. Just as a little aside, later on we're going to learn something called De Morgan's laws, which are exactly that. The fact that A union B complement is the same thing as A complement intersected with B complement, and that A intersect with B complement is A complement union with B complement. Those are the two De Morgan's laws, and the way that you would justify them would be with a Venn diagram, and now we've done so. So later on when we talk about De Morgan's laws, I won't justify them, I'll just make reference to this example. All right, last one. I have A union B intersected with A intersect B complement. So lots of steps to do. I would first need to know where is A union B, and then where is A intersect B, and so I can find out where A intersect B complement is. And then once I have A union B and A intersect B complement, then I'll be able to combine the two things with an intersection to get the actual thing I'm interested in, which is A union B intersected with A intersect B complement. Okay, so let's start with A union B. Anybody who's inside of A or inside of B or inside of both of them. So I'm doing my shading here of all the areas. Good. All right, A intersect B. A intersect B is where they overlap, which is just the middle. So there's A intersection B, and that means the complement of A intersection B will be everything else, everybody except for the middle. So only A, only B, and also the exterior. Okay, so last part that we're looking at, I'm looking at A union B intersected with A intersect B complement. So it's an intersection. We need to know, what do these two things have in common? What does the Venn diagram for A union B and A intersect B complement, what's shaded in common for both? And I'm noticing, number one, the middle didn't get shaded for both, so I will not be shading it. The exterior did not get shaded for both, so I will not be shading it. However, only A, that got shaded in both my diagrams, so the only A part will get shaded here. And the only B got shaded in both diagrams, so only B will get shaded here as well. After this example, I make a little bit of a note, again, about two Venn diagrams looking identical means that you're really talking about the same thing. So again, I'm going to make reference to this example later on when we talk about De Morgan's laws.